In this video, we're going to go through the processes of how to find complex number products. So that is how to multiply complex numbers. So recall that a complex number is no more than the sum of a real number with an imaginary number. We say a real part, imaginary part. If I were to take two complex numbers and multiply them together, however, how would we necessarily do this? And the good news is, as you see I've got written here, it says to multiply complex numbers, we'll simply use distribution or the FOIL method. You know, this is algebra, so all we need to do is actually just go ahead and FOIL this out. If I had something like this, or what if I had like, 3i, which is a complex number, times 2 plus 3i, if I did something like this, we could just distribute it. So the rules of algebra apply here. So we're just going to dive right in and look at a few examples of how this is done. So, excuse me. We have examples A through C here. Let's start with example A. You notice I have 5i times negative 2 plus I. And I just want to bring this up, by the way. 5i is a complex number. If we were to write that out in standard form where it has its real part and imaginary part, it's the same thing as 0 plus 5i. But what we'll do is we'll distribute this. And we know that I is not a variable, but we're going to treat it as if it is one. And so if it were, we'd say multiplying this out, we get 5i times negative 2 would just give us negative 10. Let me do this in red here. We say negative 10i. Okay, and we say, well, now 5i plus times a positive I, well, 5i times I would be 5i squared. Okay, so this would be our product right here. The thing is, before we proceed, what we want to bring up here, and this was in a previous video, but get used to this, I squared is equal to negative 1. And the reason behind this is because recall that I is equal to the square root of negative 1. And so if we were to necessarily take I and the square root of negative 1 and square both of these, because that's what we're concerned with here is I squared, well, we'd have I squared on the left. On the right, we'd have negative 1, the square root of negative 1 squared, which they undo each other, we get negative 1. So wherever you see an I squared, we can substitute in the number negative 1. So what that means is on this product, what we're going to do is we're going to rewrite this as negative 10i, and wherever we see an I squared ever, we're going to substitute in a negative 1 right there. Okay. So what this means is we actually simplify this out to be this negative 5, I'm going to put this negative 5 in front, plus a negative 10i. And the reason why I'm writing it like this is because this looks very much like a complex number in standard form, where we put the real number in front and the imaginary number in back. Okay, so now let's look at an example where it's not just simple distribution, but we've got a grander distribution. We're going to FOIL. Okay, so just like any other FOIL, we'll go ahead and get started here. We say 7 times negative 1. This comes out to be negative 7. We'll take 7 times 2i. That would be a grand total of 14 i's. And we say, okay, so negative 4i times a negative 1 is positive 4i. And then we say negative 4i times a positive 2i is negative 8i squared. So a couple things we have to actually do here. We want to simplify this. And I notice that I've got an I squared again. So when we rewrite this, we're going to rewrite that I squared is equal to, let me write this a little bit cleaner here. I squared, we're going to rewrite that as negative 1. Also this, we have a couple of like terms in the middle we can combine here. So when we re-scribble this, we get now negative 7. If we were to combine 14 i's plus 4 more i's, we'd have a grand total of 18 total i's. And in this case, we'd rewrite this as negative 8 times I squared, which is negative 1. So now, cleaning this up further, we'd say, well, then this is equal to negative 7 in front, our positive 18 i's in the middle, and we say, well, negative 8 times negative 1 here would be a positive 8. So now we're responsible for combining these two like terms, the real parts here, and those combine out to be a positive 1. So we get 1 plus 18i. So we would say the product of these two complex numbers is the number 1 plus 18i. So to take a complex number times a complex number, we certainly get a new complex number here. Okay. One thing I want to mention before we go to this last example is simply this. This negative 8i squared, since we're going to be plugging in a negative 1 every time we see I squared, one really simple way to simplify this is if I had like a negative 8i squared. Once you get used to this, since I squared is negative 1, you could really just rewrite this as just positive 8 and drop the I squared. So if I were to have any number, we say a times I squared, we could rewrite this as like opposite of a. Okay. Cool. This last example, before we go ahead and FOIL this out, I want us to recognize one thing about it is these two numbers are what we refer to as complex conjugates. That is, they are the exact same things in the parentheses except for one of these is positive and one of these is negative. And anybody that's had some experience with factoring knows that anytime you multiply out conjugate pairs, we say a plus b, a minus b, for example. Let me fix that. A minus b, you get a difference of two squares, or that a difference of two squares factors into conjugate pairs. So when we multiply this out, you're going to see that our middle terms drop out. So let's go ahead and FOIL this. We say 6 times 6 is a perfect square of 6 is 36. We say 6 times negative 3i is negative 18i's. But in the inner here, we'd say a positive 3i times 6 is positive 18i's. And so those will cancel. You can see that these will cancel here when we combine like terms. And then positive 3i and a negative 3i gives us negative 9i squared. So a few things here. When we combine these like terms in the middle, they drop out, and we just get 36. And we say, well, negative 9i squared is what we had on the right. We also know that I squared is equal to negative 1. So 36 minus 9 times negative 1. But just like we said over here on the right, if I had negative 9i squared, you could just rewrite that as positive 9, since that I squared is going to flip its sign. But that's what we truly end up with, is 36. A negative 9 times a negative 1 is a positive 9. And so we end up with 45, which I do want to point out here is purely real, which is a really cool consequence of this. Essentially, though, what I want to point out is anytime you multiply two complex conjugates, like a plus bi, a minus bi, let's go ahead and FOIL this out. We would get a squared minus a bi, but we turn right around and get plus a bi. So again, our complex conjugates multiply out and get our middle terms to cancel. And then we get minus b squared I squared. And furthermore, we get a squared minus b squared I squared. Well, I squared is negative 1, so we end up with a squared just plus b squared. And so the nice thing about this is it's always purely real. So one really profound consequence of multiplying complex conjugates is that you always get a purely real answer. Okay, cool.